The focus of this course so far has been on sending notifications from apps on phones and tablets to wearable devices. But now I'll show you how to create apps that actually run on the watch. I'm still working with the physical phone, but now I'm back to using an Android emulator for the watch, and they're paired together. I'll go to the Android Studio welcome screen and create a new Android Studio project. I'll name the project My Wearable Application, and I'll set the package name to com.example.android.wearable. I'll initially create the project on my desktop so it's easy to find, and then I'll click Next. I'll set my minimum SDK for the phone and tablet app to API 18. That's Android 4.3, the earliest version of Android that can connect to Android Wear devices. And then I'll select Wear, and that will create a second module or app. This app will have a minimum SDK of API 20. That's Android 4.4 or the first version of KitKat Wear. That will allow you to target the broadest selection of devices that are currently in the market. I'll click Next, and then I need to select an activity for my mobile app, the app that's going to run on the phone or tablet. I'll select the blank activity template and click Next. I'll accept all the settings on the naming screen and click Next again. Now I'm asked to create an activity for the wearable device. I'll choose the blank Wear activity template, and I'll click Next, and once again I'll accept all of the names. I'll point out that there are two layouts involved, one called Round Activity Main and one called Rect Activity Main. I'll talk about those in a little while. I'll click Finish, and after a few moments my new project is created. I'll look at the project window and show that the two modules are named Mobile and Wear. The Mobile project is for cell phones and tablets, and the Wear project is for the watches. Now, when you package your application with a signed certificate and you distribute it through the Google Play Store, you'll distribute these applications together. When a user downloads the app for the cell phone, the wearable app will be automatically synchronized to their watch. But during development, you need to load the two apps separately. Notice up here that there are two run configurations created automatically, one for the mobile app and one for the wearable app. I'll load the mobile app first. I'll choose that run configuration and then click the Run button. It'll take a few moments to build the application the first time I do this. When the Choose Device dialog appears, I'll make sure I select my handheld device, in my case a Nexus 6. I'll click OK, and then I'll shrink Android Studio down so I can see my Nexus 6 in the background, and after a few moments, the app is loaded. So that's the app for the handheld device. Now I'll go back to Android Studio, and this time I'll choose the Wear configuration, and I'll click the Run button again. Once again, the build process kicks in, and it might take a few moments the first time you build and deploy this module. This time, I'll choose the emulator for the wearable device. If you're working with a physical watch, you should choose that instead. And once again, I'll click OK, and I'll minimize Android Studio, and after a moment, the wearable app appears on the watch. Notice that it shows the text Hello Square World. I'll talk about that message in a later video when I describe how layouts are selected at runtime on a wearable device. But if you've gotten this far, you've successfully built applications for the handheld and the wearable devices, and you've deployed them for development and testing. When I created my brand new application for a wearable device, it displayed the message Hello Square World when it first appeared on the screen. I'm going to describe why it's doing that and how you can take advantage of some of the patterns that are available in a brand new wearable app. In Android Studio, I've opened the project multiple layouts from the exercise files. This is exactly the same as the project I just created, so you can either open this one or continue on with the previous exercise. In the wearable app, in the Java folder, I'll open the main activity class. The code here is very similar to what you see when you create a brand new application for phones. After the call to the superclass's onCreate method, there's a call to set content view, and it's loading a layout file. I'll open that layout file, which is in the Resources folder's Layout subfolder, and I'll reformat it. I used the keyboard shortcut, but you can also go through the menu and choose Code, Reformat Code. So the layout for a watch starts with an element named Watch View Stub, but there isn't any actual viewable content here. Instead, there are two sub-layouts, one named Rect Activity Main and one named Round Activity Main. As the app comes to the screen on the watch, the Java code is executed and the root layout is opened. The root layout then chooses a layout based on the shape of the watch. And I'll go to the Resources folder, to the Layout subfolder, and I'll open Rect Activity Main, and I'll also reformat that one so it's easier to read, and I'll see that there's a device ID named where_square, and here's the string resource for Hello Square World. And I can Control or Command click into that, and I'll see the actual text. Now, if I run the same app on a watch with a round face, then I'll see this activity file, Round Activity Main. And the code here is almost exactly the same, except that the device ID is where_round. You can look at these layouts in Design View in Android Studio, but when you click the Design tab, you won't see a watch face by default. It'll default to whatever phone template you might have looked at previously. To change that, pull down the list of available templates and select the shape of watch you want to look at. And that's what the round watch would look like. Then I'll go back to the rectangular watch and look at that in design mode, and I'll need to explicitly change to the square watch here. And I see exactly what I'm seeing on screen. Now, if I want to make a change, I can go into the layout and add various attributes. So for example, I'll go into my linear layout and I'll set its background attribute to a color that's built into the Android SDK. I'll select @Android:, then color, and then I'll choose Holo Blue Bright. I'll look at that in design mode, and I see that it looks pretty good, but now the text is washed out. So I'll come down here to the text view, and I'll set its text color, and once again I'll choose Android, and then color, and this time I'll choose black. And I'll look at that in design view. Then to fully test this, I'll run the app again, making sure that I chose the Where configuration. When the Choose Device dialog appears, I'll choose the emulator for my watch, and then after a moment, the wearable app is reloaded. And there are my new colors. So designing your interface for your apps typically needs to be done twice, once for square faces and once for round faces. And there are a lot of tools available for this purpose in the Guidelines for Android Wear User Interface Design, and I'll talk about that in the next video. This course is primarily oriented for developers who are going to be building the code that makes Android Wear apps go. But it's worth talking a little bit about design recommendations when you're creating an Android Wear app. Google provides a set of design recommendations for Android Wear. You can find them at this website at developer.android.com/design/wear. It includes topics such as principles and UI patterns, available widgets that are included in the Wear SDK, and how to structure your wearable apps. Here are some of the most important topics to pay attention to. First, when you're designing an Android Wear application, you want to design for glanceability. When users look at watches, they look at them quickly. They don't spend a lot of time on them as they might with a tablet or a phone or even a desktop computer screen. So you want to design for what Google calls the corner of the eye. When you glance at the watch, you should be able to pick up the information you need very quickly. Each screen in an Android Wear app should do one thing and only one thing, and do it really quickly. You don't want to overload your design so that the user has to navigate through a whole set of steps or a lot of information. And you don't want to be what Google calls a shoulder tapper. When users first put on an Android Wear watch, they sometimes react with annoyance at the number of notifications that are making the watch vibrate. You only need to make the watch vibrate if your notification is very, very important. Otherwise, You should just assign your notifications and other application elements a medium level of priority so that the user isn't overwhelmed. You can learn more about the principles of Android Wear design at this webpage at principles.html. There are some common UI patterns that Google talks about. The card stream is a series of cards that inform or ask the user to take some action. Each card can have a little bit of information, and you can show the user a series of cards. When you give them a series of cards, they stack vertically, and the user swipes upward to see the next card. You can also structure your information in a series of pages. Pages scroll from right to left. Cards are stacked vertically. For example, a 2-page sequence might include a single page with a little bit of information, and then another page that has an action button. And action buttons are very important. They're large buttons that fill the screen and are easy to tap without having to look too hard at the watch. Again, you can find information about UI patterns at the Android developer website on the patterns.html page. Here are some other design issues to pay attention to. You want to design your app for multiple shapes and sizes. Just as with phones and tablets, there are many different watches in the market. Some of them are round, some of them are square, some have a larger number of pixels, some have a lower pixel density, and so on. And you want to design and test with as many different variations as you can. Now, it's not always practical to have multiple watches available, so that's where the Android emulator can be incredibly valuable. You can set up as many virtual devices for watches as you like, with different shapes and different pixel densities. You also want to design for readability. You want to test your layouts for glanceability and readability. Look at the watch quickly and see if you can pick up the information you need without spending a lot of time on it. And then finally, separate the information into digestible chunks. This goes along with the UI patterns of cards and pages. Instead of trying to show the user everything all at once, break it down into small pieces and let them go to the information that they need. And once again, you can find more information on the website in the Style page. So that's an introduction to some of the issues you might run into as you're designing your Android Wear apps. I recommend looking at successful wearable apps that you can download from the Google Play Store. You can search in the Google Play Store for apps for Android Wear. Download and install the free ones and see what other designers have done to create their own Android Wear applications. The most common screen layout in an Android Wear app is called a card. You can use standardized card layouts that are defined by existing classes from the SDK. In this demonstration, I'll show you how to use the card fragment class to create a simple layout that displays a message. It looks good on both square and round watch faces without having to do a lot of design and programming work. I'm working in the project Card Fragment. In this project, I've included a couple of graphics in the drawable folder. The icon file is 48 by 48 pixels, and the photo file is 800 by 800. That'll be used as the background for the card I'm going to design. In this application, in the layout folder, there are 3 files. The beginning layout file is activitymain.xml. It has references to the other 2 files for rectangular and round watch faces. But because I'm going to be using the card fragment class, which adapts automatically to different shapes of watches, I don't need these extra files. So I'll go to the project window and find those files, and I'll delete them. Now I'll go back to the activitymain.xml layout file. I'm going to change the root element of this file from watchViewStub to box inset layout. That'll be the root element that will contain my card fragment. Next, I'll delete a couple of attributes I don't need, the references to the rect layout and the round layout. Then I'll reformat the code to make it a little bit easier to read, and I'll make a little bit of space between the beginning and the ending tags. Next, I'll add a frame layout component. This is the same layout component you use in cell phone apps that can contain a single item that you add programmatically at runtime. I'll set the width and the height to match parent. Then I'll go back up here, and I'll add an ID, and I'll set that to frame_layout. That will let me reference this layout from my Java code. Finally, I'll add one more attribute named layout_box. That's a member of the app prefix, and I'll set it to a value of bottom. That will cause my card to float to the bottom on a square watch face. I'll use an intention action and collapse that empty tag, and that's my finished layout file. Now, I want to add content to this layout at runtime, so I'll go to the main activity Java class. In the onCreate method, I'll get rid of these last few lines of code that are referencing the watch view stub from the original layout. I'm still loading the activity layout, activity main, but the next step is to add a card fragment using the Fragment Manager class. This is the same Fragment API you would use on a cell phone app. I'll create a Fragment Manager object that I'll name Manager, and I'll instantiate it with the method getFragmentManager. Now, notice I'm not worrying about support versions of these classes, that is, compatible versions for older versions of the Android operating system, and that's because this code is going to run on a watch, and I know that watches only run recent versions of Android. Next, I'll create a fragment transaction. I'll name it transaction, and I'll get that reference by calling manager.beginTransaction. Next, I'll create my card fragment. This is a member of the wearable support library, and it's worth mentioning at this point that the reason it's available is because it's referenced in this Gradle build file. Notice the references here under Dependencies. I'll go back to the code and continue. I'll instantiate the fragment object with this code, cardFragment.create. There are two versions of this method. The first takes two strings or character sequences, and the other one also accepts an icon resource. I'll start with the version with just two strings. The first string is the title, and this should be a very short string. Now I've populated my strings.xml file with a couple of strings I'm going to use, a card title and a card description. So I'll come back here, and I'll pass in the values by calling the getString method twice. The first time I'll pass in r.string.cardTitle, and then I'll call getString again, and I'll pass in r.string.cardDescription. So now I have my fragment object that defines what's going to be displayed on the watch. Next, I'll add the fragment to my fragment transaction with transaction.add, and then I'll pass in the container ID, which is r.id.frameLayout. I defined that when I defined the layout, and then I'll pass in the fragment object. And finally, I'll commit the transaction. I'll clean up the code a bit, and now I'm ready to test. Now, because I added this code in the onCreate method, my card fragment should appear as the application is launched. I'll make sure that I've selected my Where Edit configuration, and then I'll click the Run button. If you see the Choose Device dialog, select the emulator or physical device you want to test with. I'm going to select both emulators for the round and square watch faces, and then I'll click OK. It'll take a few moments to build and then display the app on the watch faces. If this is the first time you've seen this happen, you might get another notification that says that the app has been installed on the device. And when you're finished looking at the card, you can click and drag it to the right to dismiss it. Now, I'll go back to my code and I'll add a couple of features. I'll go back to the activity layout, and I'm going to add a background attribute. That's Android:_background, and I'll use the photo that I included in my resources, withdrawable London photo. I'll also go back to the main activity, and I'll add the icon that I included in my drawable resources. That's passed in as a third argument to the create method, with r.drawable.landon_icon. I'll clean up this code a bit, and now I'm ready to test again. Once again, I'll select both of my watch emulators, and this time when the card appears, I see my background image and I see my graphical icon. Notice the layout is different depending on the watch shape. On the square watch, the card gravity is down at the bottom of the screen. On the round watch, it's just centered vertically. You can control these layout choices both in the XML layout file and with a bit of Java code, calling methods of that card fragment class. So that's a look at how to do a simple layout using the card fragment class. You don't have control over where things appear with this class. The label is always at the top and the description's always at the bottom, and the icon is always over on the right. But it's simple and easy to use, and you don't have to create a lot of custom code to get it working. The Action Page class provides another standard layout for Ware applications. It displays a circular button with an optional image and a label. You can then add a click listener method to respond when the user touches the button. I'm working in a project named Action Page, and I've added a new graphic to the drawable resources. It has a white foreground and a transparent background, and it's named icinfo.png. I'll go to my layout file, activity_main. Make sure you're working in the Ware module, not in the mobile module. I'll change my root element from box inset layout to action page. Then I'll change some of these attributes. I'll leave the width and height at match parent, but then I'll set a couple of attributes that are unique to this class. The color is the background color of the circular button that will be displayed. I'll use a built-in color of Holo Blue Bright. I'll still be using the same background, my photo from London, but then I'll also set an attribute named max lines to a value of 1. The Action Page component includes a label underneath the button. It can display either 1 or 2 lines. By setting max lines to 1, I ensure that the string won't wrap. Next, I'll set the text attribute. Once again, this is the Android prefix, and this is the string that will be displayed. I'll use my app name with @string/app_name. Now, this is the only component I need, so I'll turn this into an empty tag, and I'll delete everything else underneath it. And that's my new layout. Next, I'll go to my main activity in the Java folder, and I'll delete all this code that's using the Fragment Manager class and loading the card fragment. Because the XML layout file now refers to the only component I need, I don't need any special Java code. And I'll go ahead and test my application, running it on both my square and my round watch face. Here's the basic layout. The label at the bottom is using my app name string, and this is the circular button. If I click on it, notice that I get an automatic ripple effect, and that works regardless of which watch shape I'm using. Now I want to add the icon to the button face. So I'll go back to my code and I'll add a source attribute with Android:src. And I'll add my drawable graphic that I included in my project with @drawable/ic_info. And I'll run the app again. And this time I get the nice large button with an infographic that lets the user that they're asking for information about land and hotels. And because it's a nice large button, it's easy to find and touch on the small watch face. Next, I'll add an event handler to respond when the user touches that button. Once again, I'll go back to the main activity class, to the onCreate method, and I'll add this code. First, I'll create an instance of the Action Page class, and I'll name it Page. And I'll get its reference by calling findViewById, and I'll pass in the ID of my class. I'll go back to my layout, and I'll change the ID here to Action Page. Then I'll go to the activity, and I'll look for r.id.action_page. As always, when calling findViewById, I'll cast the return value as the appropriate class. Next, I'll call page.setOnClickListener, and I'll create a new instance of the onClickListener class. When that auto-completes, Android Studio automatically generates the stub for the onClick method that will be called, and all I'm going to do right now is call the log class, and I'll call the D method for the debug level, and I'll pass in the current activity name, main activity, as the tag, and then a message of button clicked. and I'll run the code again. Now this time, because I'm running two different instances of the emulator, only one is going to be connected to my cell phone, so only one is going to be able to send back logcat messages. I'll click on this one and I don't see any response, so I'll click on that one and I see the response come back. Button clicked. If you're running two emulators and you try to connect to the emulator from your cell phone, only one of them will be connected. So you'll only be able to debug this way with one emulator at a time. But I still like keeping both emulators open, especially when I'm doing design work, because that lets me see how my layouts will look on different shapes of watches. When a user takes an action on a wearable app, it's sometimes useful to give them time to cancel it. You see this with notifications. I'm showing my live device, a Nexus 6, connected to my emulator. And in the Android Wear app, I'll go to Try Out Watch Notifications, and then I'll send a notification. Then on the emulator, I'll dismiss the notification and immediately swipe upward, and I see an undo button with an animation. If I don't select that button within the available time, the notification is dismissed. But now I'll send the notification again, and I'll dismiss it again, and swipe upward again, and this time I'll touch that button, and I undo the dismissal. You can create this same sort of confirmation user interface in your own wearable apps. I'll get rid of this notification, so I'm starting from scratch. In Android Studio, I'm working with the project Confirmation, and I'll show you how to create the Confirmation UI with a class named Delayed Confirmation View. This is a widget that goes onto your layout. You set the amount of delay in the confirmation view, and then it provides a nice animation. You then get events in your Java code indicating either that the delay ran to completion or the user selected the view, presumably to cancel the action. You can then show an animation describing either completion or cancellation with your own custom message. So I'll start in the layout file, activitymain.xml. Right now, I only have a couple of text view components, and I'll look at the layout view in XML mode. I'm going to place my confirmation view right between the two text views, and notice that I've wrapped the second text view and the delayed confirmation view inside a linear layout with an orientation of horizontal. So the component I'm about to add that's going to display the confirmation view will be to the left, and the text view label will be to the right. I'll start typing a tag name of android.support.wearable, and then I'll scroll down and select the delayed confirmation view component. Then I'll add a bunch of attributes. First, I'll add an ID, and I'll add the usual ID prefix, and then set an ID of delayed_confirm. Next, I'll set the layout width and layout height, and I'll set them both to 40 dp. Next, I'll set the source attribute. I'm going to be using this PNG file that's in the drawable folder, iclock.png. Notice that it's white with a transparent background. I'll set the attribute Android:src, and then within quotes, add drawable, and then IC_clock. Now at this point, you might not get all of the autocomplete in your typing that you want, but these attributes will be recognized. Next, I'll set a few attributes that are in the app prefix. These will describe some of the appearance of the component. The first one is named circle_border_color. And I'll set that to one of the colors that's included with the Android SDK of background_light. Next, I'll set an attribute named circle_border_width. And I'll set that to a value of 4 dp. And finally, one named circle radius. And I'll set that to 16 dp. And that's the complete tag. Now, if I look at this in Design View, I won't really see anything update. Everything's still invisible. And that's because my linear layout is set initially to a visibility of invisible. But if I click around in here, I can clearly see that there are two components: my new delayed confirmation view and the text view that was already there. Now I'll add some code in my main activity class. I already have a private field named isRunning set to false. I'll be using this to track what's going on as the user navigates through the application. But I'll add another private field, and this one will be an instance of the class delayedConfirmationView. I'll name it mDelayedView. And I won't instantiate it here. I'll do that in the onCreate method. I'll go down to the onCreate method and add code here after the call to set content view. I'll call mDelayedView, and I'll get its reference by calling findViewById, and I'll pass in r.id.delayedConfirm. And I'll complete all that code, including casting the result of findViewById. This code's getting a little wide, so I'll expand my editor to full screen. My next step is to add a listener. The listener will react when either my delayedConfirmationView completes its action or the user selects it. I'll need to add two methods for this. They're members of an interface named delayedConfirmationListener. So I'll add implements and then delayedConfirmationListener, and that expands to include the parent class of the interface. Then I'll use an intention action and implement the methods. They're named onTimerFinished and onTimerSelected, and those are added at the bottom of my code. I'll come back to those later, but my next step will be back in the onCreate method, and now I'll register the listener like this, with mDelayedView.setListener, and I'll pass in this as the object that will react when the events occur. You also have control over how long the delayedConfirmationView takes to complete its action, and you set that with a method named setTotalTimeMS. I'll pass in a value of 3000, and that's 3000 milliseconds or 3 seconds. Now my next step is to launch the timer. I'll expand this code here, and you'll see that I've already added code to handle a click event when the user touches the watch face. I'm reacting to the onClick listener for the relative layout that contains the entire interface. And I'll add this code. I'll start with a conditional block, and my expression will be if not isRunning. I want to make sure I'm only launching the timer if it's not already running and already visible. I'll call my existing method called showTimer and pass in a value of true. And then I'll call a method of the delayedConfirmationView named start, and that launches the delayedConfirmationView's action. So first I'm making it visible, and then I'm starting it. And then I'll flip that flag isRunning and set it to a value of true. And now I'm ready to launch for the first time. Let's take a look at the code before we see what it does. Once again, I've added my delayedConfirmationView to my layout, and I'm using my own custom icon, in my case, a clock. Then in my Java class, I've gotten a reference to that component, and then I've set a few properties, and I'm launching it here after making it visible. I'll run the app on my emulator. Because I set up the click handler on my watch face, I can now click anywhere, and I see the animation launch. But right now, I don't have a good way of running it again. So let's go back to the code, and I'll fully implement these two event handlers. I'll start with onTimerFinished. This event occurs when the component runs to completion. I'll handle that by calling my showTimer method again, and I'll pass in a value of false, and I'll also reset my flag with isRunning equals false. Then I want to show the user what happened. I'm going to use a built-in activity called the ConfirmationActivity class, but I'm going to be using the same activity regardless of whether the user lets the component run to completion or cancels. And so I'll create my own custom method. I'll name it showConfirmation. It doesn't exist yet, but I'll mock it up by calling it here. And I'm going to pass in a constant named ConfirmationActivity.successAnimation and a string of confirmed. Now again, this method doesn't exist yet, so I'll use an intention action and create it. My two generated arguments have been named based on what I'm passing in initially, But I want to be able to use this method for either success or failure, so I'm going to rename these to more neutral names and call them animation and message. And here's the code. First, I'll create an intent object, and I'll instantiate it with new intent, and I'll pass in this as the context and confirmationActivity.class as the class. Next, I'll add a couple of extras. I'll call intent.putExtra, and I'll add two extras to indicate the type of the animation and the message that will be displayed. The first extra will be the type of animation, and I'll pass in the key with this constant, confirmationActivity.extraAnimationType, and then I'll pass in my animation argument. I'll duplicate that line of code, and for the second extra, I'll pass in a key of extra_message, and I'll pass in my message that I passed into the method. And then finally, I'll start the activity. So now I have the code in place to handle what happens when the user lets the component run to completion. Let's test that much. When the app reloads, I'll tap anywhere, I'll let the component run to completion, and then I see an automatically generated success message. I'll let that run again, and you'll see that it includes a graphic, a check mark, and my custom message, which I set as confirmed. Now I'll go back to the code, and I'll add my last little bit of custom code, and I'll place this in the onTimerSelected method. This code will be executed if the user touches the component before it runs to completion. And then once again, I'll call showTimer and pass in false, and I'll also set my isRunning attribute to false, but I'll also call mDelayedView.reset, and that will reset the confirmation view so that it can run again from scratch. Then I'll call my showConfirmation method, and this time I'll pass in an animation constant of confirmationActivity.failureAnimation and a message of canceled. Once again, I can let the confirmation view run to completion, but now this time, I'll touch the confirmation view and I get the canceled message. I have one more little bit of code to review. Notice in the onClick event handler that I've wrapped all of the code to make the timer visible and to start it up again with a conditional block that examines the isRunning Boolean field. This guarantees that if the component is already running, and if the user then touches the watch face around it, that the component won't just randomly restart. I'll run the app one more time and show the result of that. I'll click here, and then I'll click around on the watch face while it's running, and it doesn't restart the component. But then once again, I'll cancel that operation and see the canceled message. Notice that the success and failure animations go by pretty quickly. You don't have control over how long those take. That's defined within the confirmation view component, and it's not changeable by the developer. But this component, along with a bit of Java code, lets you create a simple confirmation user interface that lets the user catch issues if they react in time after they've touched something in your wearable app. Android watches can go into what's known as ambient mode for a few different reasons. The watch display typically times out after some period of inactivity, or the user can turn off the display by pressing a watch fob or placing their hand over the display. You can emulate this with the Android emulator by pressing the software button in the top right corner. When you click on that button, the watch goes into ambient mode. And the watch face typically will show a black background with a white foreground. This is how the simple watch face reacts. Then I'll touch the button again to take it back to normal display. You can try this with a variety of watch faces. For example, this is the Aviator watch face, and this is what it looks like in ambient mode, and then back to normal mode. And I'll go back to my simple watch face. You can implement always-on functionality in your own applications. Now, by default, when you run a custom application and then the watch goes into ambient mode, the application will be dismissed and you'll go back to the current watch face. So I'm running an app that doesn't have always-on functionality. And then I'll go into ambient mode, and I see the ambient watch face. Then I go back to normal mode, and the app doesn't come back. When you create an app that has an always-on activity, you will be using more battery life, so you only want to do this for apps that really benefit from it. Here are the steps. I'm working in a project called Always On, and I've already made some changes to the manifest in the Where module. First, I've added this uses permission tag with the name of wake_lock. That allows the app to lock itself into place on the display. It's just the permission. It isn't actually doing it yet, but it will allow the app to do this. And then I'm going to be using a class from a library called Wearable, and I've added this uses library tag to the application with the name of com.google.android.wearable. That in turn is made possible in the build.gradle file for the Where module, where I've added a provided attribute referring to wearable 1.0.0. And that's in addition to the compile attribute that might already be there in a default application. So that's the basic infrastructure. The next step is to add code in the main activity, or whichever activity it is that you want to stay alive when the watch goes into ambient mode. I'm going to change this class's superclass from activity to wearable activity. If you don't see wearable activity available, once again, check your manifest and make sure that you've referenced this uses library tag. Once you do that, you'll have an extra import statement, and you can delete it or just optimize your imports. The next step is to call a method of the wearable activity class called setAmbientEnabled. That should be called in the onCreate method. And now this activity can stay alive when you go into ambient mode. But that's not enough on its own. If that's all the code you add, then you won't like what you see. If your app is on the screen and the device goes into ambient mode, nothing will change, because you've said it's okay to stay alive, but you haven't done anything to change how the display looks. So the next step is to handle a couple of events that will be dispatched by the wearable activity class. This class has two methods that you need to override. They're called onEnterAmbient and onExitAmbient. And I'll create the basic methods here by typing the beginning of the method names and then accepting them. Now, before I add any more Java code, let's take a look at the activity layout. There's only one in this application. It's in the usual place, and it's called activity_main.xml. It has a text view component with an ID of text view and a relative layout with an ID of layout container. Notice that the box inset layout has a background color of holo blue light, and the text view has whatever is the default text color, and we'll say for the moment that it's black. In my main activity class, I already have references to those widgets, the text view and the layout container. And so I'm going to change their colors in the two event handler methods. I'll expand the width of my editor, and I'll start with the onEnterAmbient method. First, I'll change the background color with mLayoutContainer.setBackgroundResource, and I'll pass in one of the colors that's included in the Android SDK with Android.r.color.black. Then I'll change the color of the text view with mTextView.setTextColor, and I'll pass in a constant of color.white. I'll also make this text a little bit easier to read by turning on anti-aliasing with mTextView.getPaint.setAntiAlias, and I'll pass in a Boolean value of true. Now I need to handle the event that happens when the watch goes back to normal display. I'll be calling these same three methods, so I'll copy and paste them down here, and I'll just change the values that I'm passing in. For the background resource, I'll change back to holo blue light, and for the text color, I'll set it to black, and then I'll turn off anti-aliasing. And now I'm ready to test my app. I've enabled ambient handling, and I've added the code to change the display when the watch goes into ambient mode. So I'll run the app again on the watch. This time when I go into ambient mode, instead of going back to the watch face, I see my display change. And when I go out of ambient mode back into normal display, I return my display to its original settings. So that's the basics of how you deal with ambient mode in a wearable app. There's a lot more you can do with wearable apps in ambient mode, including periodically updating them to show a countdown timer of some type, the number of steps the user has taken based on some sensor in the watch, or anything else that your app is interested in. But again, you only want to use this feature for apps that really need it. Keeping an activity alive at all times takes battery power. So you only want to use the feature if the app will really contribute something to the user's experience of wearing a wearable device. You can receive voice input from within any wearable app by launching a special activity. Just like your own custom activity, it will return a result. The result will be whatever the user speaks. To demonstrate this, I'll start in the application named Voice App in the main activity class. I want to launch something called a voice recognizer. And to do this, I'll handle a click event on my main layout. I already have a reference to my main layout container named mLayoutContainer, so I'll add code in the onCreate method with mLayoutContainer.setOnClickListener, and then I'll pass in a new instance of the onClickListener interface. That generates the onClick method. And here I'll call a new method that I'll name DisplaySpeechRecognizer. That method doesn't exist yet, so I'll use an intention action and I'll create it, and I'll make sure to place it in the main activity class. Here's the code you need to open up that special activity and accept voice input. Create an intent, and I'll instantiate it with new, and then I'll call the constructor method, and I'll pass in a constant of a class named RecognizeRIntent. The constant is ActionRecognizeSpeech. So you're saying this intent will open up a special activity that knows how to recognize speech input. Next, I'll configure the activity. I'll call intent.putExtra, and I'll pass in a key and a value. Both will be constants of the RecognizeRIntent class. The key will be RecognizeRIntent.ExtraLanguageModel, and the value will be RecognizeRIntent.LanguageModelFreeForm. That means the user can speak anything. And finally, I'll start the activity with startActivity for result. I'll pass in the intent, and then a constant that I'll need to create. I'll name the constant SpeechRequestCode. Then I'll use an intention action, and I'll create the constant, and then I'll set its value to any integer value. I'll use a value of 1001. So that's the code that will launch the intent. Next, I need to handle the result. And again, this is just like creating your own custom activity that knows how to pass back values. I'll create some space after my new DisplaySpeechRecognizer method, and I'll override the method onActivityResult. I won't need the call to the superclasses version of the method, but when this method is called, I'll receive a request code, a result code, and data. As always, when evaluating a result, you should make sure you're coming back from the right activity. So I'll create a conditional block, and the condition will look like this. If the request code matches my constant, speech request code, and the result code matches the value result_OK, then I know I'm coming back from the right activity, and I should have a value I can use. The value will be returned in a list of strings. It's possible to get more than one result. So I'll declare a list, and this is your standard Java utilities list, and I'll set its generic type to string. I'll name it results, and I'll get its value by calling the data object's getStringArrayListExtra method. It looks like this: data.getStringArrayListExtra, and then I'll pass in a key. And once again, this will be a constant of RecognizeRIntent. The name of the key is extra results. Now I'm going to assume I'm only getting a single value back, so I'll create a string variable and I'll name it spoken text. And I'll get its value with results.get, and I'll pass in a value of 0. You can add some more error handling. For example, you might want to make sure you're getting back only one result, and you might want to make sure you're getting back a result at all. Now, I'm going to display the result. My layout has a text view control. It has an ID of text view, and so I'll change its appearance to display the text that the user spoke. I'll get a reference to the text view component. I'll just name it TV, and I'll call findViewById and pass in r.id.textView. And I'll make sure to cast the result as a text view object. Then I'll set the text value of that text view object, and I'll start with a literal string of you said, followed by a line feed, and then the spoken text. So the goal now is that when the user says something, after a certain amount of time out, that special activity will return the result to my activity. I'll receive the result and display it on the watch face. So now I'm ready to run the app on the watch. On my system, it sometimes takes quite a while to load the app onto the watch, so be patient. I've also found that it runs faster on a Mac than it does on Windows, but your mileage may vary with different hardware. One thing I should mention is that I'm testing this with an actual physical device, not with an emulator, because as I mentioned previously, the Android emulator does not accept voice input. Also, I've made sure that I've connected my physical device to an Android cell phone. Voice recognition depends on Google's servers, so the voice input is accepted by the watch and it's sent to the cell phone. The cell phone uploads it and sends it to the Google servers, and then the result comes back through the same chain of hardware. And so now the app has loaded onto my watch, and I'll touch the watch face. San Francisco. As you speak, you should see a little animation, and then you should see what you're saying displayed on the face. Then when you come back to your app screen, you should see the result displayed on the screen. I'll try it again. Hong Kong. You can try it with different phrases. For example, I'll try Landon Hotels. Landon Hotels. And you'll see that brand names aren't always interpreted correctly. It depends on the profile of the brand name. I'll try Google. Google. And unsurprisingly, that works. So that's a look at how you can use your Android Wear app to accept voice input from the user. Again, you're just opening an activity and receiving a result, and the key is to use the activity that's included in the Android Wear SDK.